I'm the new co-executive director for the South Big Data Innovation Hub. We're based here at University of North Carolina, Chapel Hill, at the Renaissance Computing Institute, or RENCI, as many of you may be familiar. Our co-managers of the hub are at Georgia Tech, and I'll list those names at the end. I'm co-presenting today with my colleague Mike Conway, who is a developer at RENCI and helps to lead our infrastructure working group. So the federal government, and particularly the White House, recognized the need for greater investment and a coherent strategy around big data research and development. They initiated an initiative in 2012, investing $200 million across 6 agencies. In 2014, the National Science Foundation said, well, we really need to focus on regional issues in the use of data science and development of public-private partnerships. So they've invested about $6 million in 2015 in founding 4 big data regional innovation hubs. So there's one in the West, one in the Northeast, here in the South, so you're all in our region, and one in the Midwest. And as part of that, they are also providing $10 million in funding across all 4 hubs to fund some partnerships, to fund some applied research, where we're applying data science to real-world problems. So the National Science Foundation, I don't know how many of you are familiar, typically funds kind of basic research. So they fund basic research in critical technologies and in data science. They fund some infrastructure development through the DIBS program. They fund education in computer science and data science. But the hubs is something new for them. This is really kind of breaking new ground, is funding partnerships, connecting academic researchers with industry, with nonprofits, with government, to apply data science, to apply computer science tools to help solve real-world problems. So as I said, there are 4 regions, 4 hubs. Renee Beston is the executive director at Columbia for the Northeast Hub. Melissa Cragen is the executive director in the Midwest Hub. That's based at University of Illinois Urbana-Champaign, where the Supercomputing Institute is. Meredith Lee, who's been also very active in the Maker movement, is the executive director in the West Hub, based at Berkeley. And then myself and Renata Rawlings-Goss are here in the South. And we go everywhere from Texas to Delaware. That may not be quite what you think of as the South, but they were following census borders there. So what are the goals of the hub? Well, first and foremost, to stimulate agile and sustainable national big data innovation ecosystem, both at the regional level and at the national level. Accelerate partnerships between people across sectors, business, academia, government, nonprofits, who apply data science and analytics to advance science, to address societal challenges, and spur economic development in the region. So right now, we're still in startup mode. So what I'm telling you now may change a little bit as we're moving around the region and finding out what people want and need. But the primary goal, as I said, is helping to build, accelerate public-private partnerships, grow communities of practice around different verticals, which I'll describe in a moment, connecting data scientists with domain scientists, with industry and practitioners to develop sets of best practices, share lessons learned, and success stories, not unlike what you're doing here at PyData. Facilitating data sharing and shared cyber infrastructure collaborations, resources, and services, and Mike will talk about this momentarily, and building data science capacity through facilitating data science education and workforce development. So we had an all-hands meeting in December, bringing together 200 and about 50 participants who formed into 68 teams. And they submitted proposals to the NSF, and the NSF will be about to announce the winners of those proposals to launch new projects in the coming year. And there will be another call for proposals for funding coming up this fall. We're still in startup, so we're setting up an advisory board. As I said, the spoke proposals, the first round will go out soon. We're standing up some working groups, of which I hope some of you might want to help participate. We've developed a memorandum of understanding between all 4 hubs, so I frequently get asked, how much coordination is there between the hubs? We talk weekly. We go to each other's meetings, we're having retreats, so there is quite a bit of coordination going across the country in the hubs. We're beginning to stand up some of these communities of practice around different verticals, doing some outreach to begin to hear from you. What do you need? How can we be of help to what you want to accomplish? The R&D communities, this is just an initial set. I think as we hear from the communities what they want, these may change a bit. But infrastructure is number one, data sharing, healthcare, analytics, mobile health, metro data science, or what they call smart and connected cities, privacy and security, industrial big data and energy, materials and advanced manufacturing, and natural resources and coastal hazards. So we're beginning to set up a series of community calls for people to share expertise and what projects they're working on in these problem spaces. We're also serving as a connector and convener, hosting series of workshops, some of which are focused on these verticals or focused on some of these problem spaces. We can also do some matchmaking. If you come to me and say, I need expertise in these things, I can reach into my networks or reach across networks on the hubs to find people who might be able to help you. We've standing up 3 working groups. Community engagement, right now we're working on developing some use cases for big data tools to determine the applicability for these different verticals, partnering with the high performance computing folks, particularly Exceed. The Education and Workforce Working Group, we've stood up 2 programs funded by the Computer Community Consortium, or Computing Community Consortium, of the Computing Research Association. So they funded 2 programs. One, Data Start, and I see some Data Start folks in here. Want to shout out, yay. We had startup companies. They needed expertise in data science. So we partnered them with students who wanted summer internships to take the theoretical skills they were learning in the classroom and apply it to real-world problems. And so we had a class of 6 this year to start, but we hope to expand this as we go. And September 27th, those graduate students will be presenting their work to an audience of startup folks and government folks. And I think at least one of them, maybe more, have been hired on by those companies. Georgia Tech has a program called PEPI where they're partnering faculty with industry. And the Cyber Infrastructure Group, the most interesting, important group, I think, will be mapping existing collaborations, services, and resources, identifying hub member needs, trying to facilitate distributed data sharing, computing, and analysis across institutions and partners. Focus on open source, focus on federated. And of note, it's been announced, but we're still working out the details, is Microsoft Azure. We've got $3 million in credits across the hubs that will start being awarding to projects in the fall. Other companies are also coming to us, also wanting to provide this. So look for announcements there. And with that, I'm going to hand it over to Mike Conway.
Well, hey, everybody. I was a last-minute addition, hence my artisanal badge here. I'm with Renzi, and I'm a software developer, so I'm really nervous standing up here talking to you guys because I'm just a sort of a quiet nerd. But I'm really proud to work on some of the projects I've been involved with, and particularly proud to have worked for Dr. Regan Moore, who just retired, who in his space is actually a really important leader in the field of data science and data management. So I'm going to try to transmit some of what he talks about and some of what we're doing and how it may play into all the wonderful things I see represented here at PyData. So we're going to talk about, we're talking about applying Python and R and tools like that to data mining and managing scientific data is primarily where I've interacted with Python. But we want to start talking about now, what is the context in which your Python tools, your R tools, are applied to data at some scale in collaborations, and then how is that data managed? So you have the data and the computation, and what we're really interested in is that sweet spot where those two things meet, and it's a context, I think, in which we can do sharing and partnerships in a way that is sustainable and sort of technically achievable. And that's what I'm here to talk about today. So I'm with something called the DataNet Federation Consortium, which was one of the major NSF DataNet grants that Leah was mentioning, where we're building national scale infrastructure for scientific collaboration. So this ranges all the way from the high end with things like Babar and the Large Hadron Collider, Keck and large astronomy data sets, so big data. It also includes things like sensor data. So we work with things like the Ocean Observatories Institute, gathering sensor data, being able to manage that data, share it with others, aggregate it. The same with things like NASA, MODIS, NOAA, climate data. So there's the big data side, and then there's the small data side, which are researchers working on small projects where they want to collaborate together, reuse each other's data. So that's the sort of area where we want to play. So it's about the preservation and publication of data and repeatable science. This is one of the goals we have with DFC, and I think this plays into what the Data Hub is doing. We also want to look at groups that control their data, and then they federate their data collections with other organizations. So NASA, NOAA, and RENCI may collaborate on a project. They each control their data, but they can share it as one federated collection. And again, this confluence of data and computation is the real sweet spot. And I'm getting this speeded up, so I'm going to kind of pass through some of these slides. So we have here represented, we have industry and research and academia. And the Data Hub environment, to me, is this mixing area where we're speaking the language of open source. So everything we do is open source software, and we're building both the software and the discipline in order to take these pieces and create repeatable, shareable science. Okay, so the Big Data Hub environment, it's about data management and sharing. Okay, we're doing computation, but where does that data go, and how can other people find and discover it, and how can they use it 10 years from now? So part of that is about being able to take your scientific data and derive metadata about it based on your computation, the processes, the analyses that create data sets, and be able to keep that, preserve that, and then allow that to be discovered in many different ways. It's about long-term preservation. So our background actually started with the US National Archives. So the software I work on was a narrow project for about 10 years. So how not only can we do this computation, but how can we keep this data and make it meaningful 10 years from now? So working at this intersection of big data management and computation, the kinds of excellent work that I've seen represented here at PyData. And that's, I think, where the Big Data Hub is a place for software developers to work together to innovate, to solve some of these problems, providing then a place for science to happen. Okay, so basically where we're coming from is this idea I want to introduce. It's actually a pretty simple idea, but it's unique, and I think it's spreading, is this idea of policy-based data management. So the idea here is that each data object, a product of analysis or so forth, is treated as a resource. This bridges everything from high-performance file systems to NoSQL databases. You know, just think of everything as a URL, which we're already sort of doing. So all actions on any resource that is kept in these federated data stores triggers policies at the core of the system. And those policies can range from simple replication and checksumming and fixity checking all the way to managing things like FERPA or HIPAA. You know, think about the kinds of policies that control your data. It could also be things like embargoes. So then the kinds of policies we apply are security and audit, preservation rules, data transformation, metadata extraction, etc. Okay. The idea, this is again, is what basically where Regan Moore comes from and what DFC is built on, is this idea that as you apply policies to these data you keep in your data grids, you can keep metadata about the application of those policies. The idea then is that you can then assess how your policies are working so that you can do things like show data use to NSF, so that you can show you're complying with license agreements, so that you're complying with, again, federal guidelines, things like HIPAA. Okay, the idea then is you can extend that into federated environments, other hubs, where each location enforces its own policies and controls its own policies. So this is sort of like building an internet of data, if you will, sort of below what we think of as the internet. And that internet of data is freely networked. And then, okay. So I'm wearing my iRods hat here because I also work with the iRods Consortium. So The iRODS data grid is open source software that we're using at the hub. It's a generic data management infrastructure for supporting data preservation, publication, sharing, and data analysis. And it's all based around this idea of policy management of your data. Okay, give me okay. So what I wanted to talk about is if we think about our data, what we're doing in terms of applying Python or R to computation, I want to present this idea of the life cycle of your scientific data and what the NSF at large scale is trying to do and how maybe it fits into what the big data hubs and innovation centers can offer. So it's the idea that you start with a project collection. Maybe you're doing small science, doing a survey of a particular piece of land, doing bird counts or things like that. So you have private data that's controlled by your local policies. These may be shared on a data grid, perhaps with groups, and so you have distribution policies to control, for example, embargo data among researchers. And this is where things like PyData come in. Now you introduce the idea of data processing pipelines. Your data is being analyzed, and you're creating data products, and so you have service policies that are managing this. So I run an analysis on a piece of data, I keep the inputs, I keep the parameters, and I can even keep the piece of computational code that was used to create products, and that's all kept together, and I can repeat it. Okay, we're seeing a lot of this. And then the idea is that those pipelines go into digital libraries, perhaps associated with a publication. So for example, in the R world, we work with the Odum Institute on Social Science Research and the Dataverse Network. One of the things that they're doing as part of their business now is that researchers who are publishing papers have to submit both their computation and their data to the Odum Institute, and they have to be able to run your computation and verify your results before you publish. So this is the kind of thing that these data processing pipelines and digital libraries play into. This forms reference collections, things like NASA MODIS data, for example, that are being preserved, and you have policies for representing that data for discovery and so forth, and federated into these sustained collections. And I think this is the target endpoint to me of these big data hubs. Okay. So this is just an example at EUDAT. They're really big users of this kind of approach, and this is the B2 Safe infrastructure, which is used for as a repository of scientific research data. And this is just showing different nodes on the EUDAT network and how they can manage their data through their policies and yet federate to create one topological connection. That's an eye chart. Okay. The other thing I really wanted to talk about briefly is this marriage of computation and data, and this is what we're working on right now. There's lots of ways to compute, whether you're doing something at a national laboratory or you're sending stuff to TAC using XSEED resources, or you have a piece of computation that you can put in a Docker container. These are the kinds of things we're working at. But the idea is first moving data to compute. So the big data hubs is a place to do this sort of thing. Okay, so you can, for example, we work with Cybers, who used to be the iPlant Collaborative doing Grand Challenge Biology out in the West. Okay, and so they have their researchers bring their own computation, provided as a Docker container. They put it into an environment, a visual environment, where then they can run that data and manage all the products, the input parameters and everything, back it up, track provenance. Okay, this is good for small data sets, 100 gigabytes or so. What we're working on now are also infrastructure for moving compute to the data. So if you've got petabytes of data and you want to take your Python code, for example, package it up and be able to find where that data is at rest, ship that data out, have the computation done on the data at rest, again, tracking provenance and being repeatable. These are the kind of things that are happening at the BD Hub. Yawn. Okay, so I'll let you finish up.
So stay here
Okay.
for questions. So we have a growing team, and we definitely want to hear from you. What are you interested in? How can we help? We're looking for your guidance. So with that, thank you. Close.
Any questions? A couple questions? Oh, great.
So just out of curiosity, what are your policies or guarantees for export-controlled data?
Is this like Jeopardy? Do I have like... No, I heard the music playing. I got nervous. So my dodge is I am a software developer. So what we are doing, or what I was describing is a system or a approach, a discipline in which we provide the framework for you to express your policies. So in a sense, for example, you know the way the web works because URLs and verbs behave a certain way. We're providing sort of a similar system where you run this Apache server and you can encode your export policies, for example. That's where I will leave it. We're providing the framework for you to encode those policies, and then you can audit them and make sure they're being enforced.
Okay, question back here.
Don't give him the microphone.
Too late. No, but so it made me wonder. Let's say somebody has a set of export policies, right?
Mm-hmm.
How are they going to? Is there a mechanism in either enforce or envision that would allow them to package up those policies and share them with other people who might need very much the same thing?
Yes, so think of them as little modules you can plug in. One of the main things is that your collaboration is controlled through the federations that you control administratively. So it's not just checking the IP and making sure that this is not an IP that's on the State Department list. It's about you decide what grids you federate with and then who on that grid is able to access your data. And once done, it appears as one uniform collection, whether you're going through the web or some other way. Yeah.
Okay, great. Thank you so much. This is amazing. This is the kind of stuff that gives me goosebumps. And